Right. Good morning, everybody. Hey, good to see you. Thanks for joining this very first session on the Friday. And it's great to be in Krakow. I've been here a couple of times before at 33rd Degree Conference, and it's nice to be back. Right, so the British people have kind of written history yesterday by voting to exit the European Union. And maybe we can write some history today by learning how to change the world by software. And so welcome to my talk, which is about coding a better world. My name is Wolf. I'm developer at ThoughtWorks. And I've been with ThoughtWorks for about 6 years. And this is where I learned most of what I'm going to tell you about today. So at ThoughtWorks, we've got what we like to call Pillar 3 activities, which are around kind of social justice and just kind of changing the world, as opposed to just making money by developing software. So what are we going to do today? First, I would like to share some thoughts about humanitarian software as such. What is it? It sounds like a grand word. So what do we mean when we say humanitarian software? Then I would like to introduce OpenMRS and tell you a little bit about what it is actually, what it is doing. We're going to see a live demo. So we're going to have a look at OpenMRS. We're going to discuss the tech stack. Then have a look at Bahmni, which is kind of a successor of OpenMRS. And last but not least, I would like to share some thoughts about how all of us can contribute to software systems like OpenMRS or other open source software. Right, so what does humanitarian software actually mean? So when I thought about that, and when I prepared the talk, I looked up the definition of humanitarian, and it says, it means concerned with or seeking to promote human welfare. So as developers, we like to think in terms of stories or epics, and we describe the features our customers are asking us to build as stories. So I try to express it as a story. And this has become one of my favorite stories. So as a technologist, I want to use my skills and expertise to improve human welfare. And that is super easy these days. So in the old days, kind of when my parents were thinking about, well, how can I contribute to changing the world, they probably would have donated some money to some organization and hoped that they would change the world. But with software, it is easy for us to have a direct impact. So I can sit down at home, or I can sit down with my mates, or run a coding session, a code jam, and just start coding and writing software that is being used globally and is changing the livelihood of people on a global scale. So let's move on to OpenMRS and have a quick look at what it is actually doing, what it is about. OpenMRS stands for Open Medical Record System, and it is, as the name implies, a system to keep medical records of patients. So it is used in hospitals. When people come to a hospital, they are registered, doctors are seeing them, they get some treatment, nurses are seeing them, they get the next appointment, they may need to come back. And more often than not, in the global south, we find that these kinds of activities are tracked with the help of paper. So OpenMRS often replaces paper-based records. And by doing so, it improves it improves healthcare delivery. It is an open source software, and it came into existence in 2004, so it's around 12 years old by now. And it was kind of started as a response to the AIDS crisis in Africa at the time. So at the time, NGOs and doctors in Africa were looking for a system that would allow them, for one, to capture the medical records of patients, but also to figure out how different kinds of treatments were working. So this system allows us not only to capture data, but also to analyze data. And there's a large community. So today there are thousands of developers worldwide working on OpenMRS. And to illustrate what I mean when I say it replaces paper-based records, I would like to show these two pictures. So first, this is from the JSS hospital in India, and here we see kind of boxes crammed with paper. And they used to have kind of rooms full of those boxes with paper. And in the upper left corner, you see a picture of a patient record that belongs to a mother of one of my colleagues working in India. And typically, with paper-based records, you would have a booklet like this, which, by the way, could get lost. And when you see the doctor, typically the doctor has about 60 seconds to read this booklet and to make up his mind what is the history of the patient and what should be the next treatment, and looking at the patient herself. And this is being replaced by OpenMRS. So when I go to see my doctor, I expect all the data to be there, and I don't expect my doctor to look at trying to decrypt what other doctors have written down. And so this is what it is effectively all about: replace paper-based records with electronic records. The system in itself is pretty widespread. So this is the OpenMRS Atlas, which you can get from the OpenMRS website, and it shows where it is being used. So predominantly in kind of Asia and Africa. If we were to go back in time, we would find way less in the Northern Hemisphere, say in the United States and in Europe. These are quite interesting, so we're going to have a look at those a little bit later, in the sense, well, this system probably is not certified for professional use in the United States or in Europe. So you would have bodies like the FDA, Federal Drug Administration in the US, and they would expect some quality metrics for the system. And we're going to talk about that a little bit later when I tell some stories about what kind of code I encountered when I started working on that one, on OpenMRS. So, how does it look under the hood? Effectively, OpenMRS is a data model with a user interface plugged on top of the data model. The data model is really important, and it's important to understand this distinction between core data model and just the user interface on top of it. In the data model, we find, first and foremost, a concept dictionary. Concepts are medical terms. Any medical term you can think of is encoded as what is called a concept, and there are official dictionaries, kind of standardization bodies agreed on. So, for example, blood as such is a concept, and blood type is a concept. And if I go to a doctor and they take a blood sample and they analyze it, this process is a concept as well. So everything is encoded. And particular treatment, particular diseases related to blood are concepts, and medication for such diseases themselves, no surprise, they are concepts. So we have concepts of different types. And the concepts allow us to capture data in an encoded way. So it's no longer free text, it's all based on concepts or on the underlying master data, and that allows us to analyze the data, and we can compare findings from different regions and can say, well, how many of those diseases did we find, and how many of these treatments to those diseases were effective, and let's look into a control group and things like that. Then we have the encounter, which is someone in a hospital is going to see someone. So I, as a patient, go to a hospital and I'm seeing the doctor, I'm seeing the nurse maybe, and these are two encounters. They're making an X-ray, it's an encounter, or they're taking a blood sample. There are forms for the user interface where you can kind of capture the data and kind of model the workflow or the flow in a hospital. There are observations, these are the doctor's findings, there are orders, so the doctor is telling me, well, take this 3 times a day. And last but not least, there's the patient, and abstracting from that, there are kind of people or persons, if you like. So this is the underlying data model, and OpenMRS used to come with a pretty, well, old-style front end that supported the basic flows of capturing, registering a patient, capturing information data, analyzing patient data. The architecture of OpenMRS is set up in a way that it can be extended. So there's the notion of modules. And this is where the understanding the data model is really important. So a module can be developed for OpenMRS, and it would typically start using the underlying core data model. A module can also extend the data model, can bring along some stuff. The data model in itself has been built in a way that it is extensible without changing the code. For example, for people or persons which are underneath the patient, they have attributes, and attributes have attributes types, so it's kind of a generic model. And if I were to collect information, say, about what are people doing for their living, what is their profession, and it isn't supported by OpenMRS yet, I could define a new attribute type and say this is the profession. It's of a kind of technical type string, and it can be searchable or it can be non-searchable. So as an implementer, as a user of OpenMRS, I can extend the data model and customize it to my needs without touching the code base. On top of that, as I mentioned before, we've got those modules. And as an example, we discussed concepts and kind of the importance of concepts for capturing and analyzing data. And one module colleagues of mine in Australia have been working on dealt with submitting proposals for new concepts. So you're in a hospital and you figure out, oh, there's some kind of new illness going on, or you want to capture particular effects of treatment and say, hey, I need 3 new concepts to express what I want to achieve. And so you can easily create the concepts. OpenMRS allows you to do so. But then the next question is, would these new concepts be useful to other hospitals as well? And so there is a process supported by the OpenMRS community where you can propose a concept. And it goes like this. You say, these are my 3 new concepts. And they bubble up, and they are looked at by people at a higher level, if you like. And they decide, well, I really like these new 3 concepts. Yes, we should take them into the standard concept dictionary. Or they may say, excellent thinking, I really like the 3 concepts, but you may have missed that there are 3 similar concepts, and you may want to start using these instead, so don't reinvent the wheel. Or you may just say, well, this is really useful to you, and keep using it, but we don't see that it is of wider interest to the community using OpenMRS. So these are the 3 possible outcomes, and the module supported this workflow. So the module for proposing a concept allowed you to submit your proposal and to get the response. And these are extensions of OpenMRS by modules. So let's have a look at OpenMRS and see what it is doing. So what I did is I downloaded the standalone reference package of OpenMRS. This is available via openmrs.org. So it comes just as a fully compiled package. It contains embedded MySQL database and an embedded web server. So you just start a single jar, and that's all you need to do to run this. So I'm logging in as, sorry, this should be lowercase, administrator right now. And we can have a look around and say what can I do. So this is system administration, but I want to go to the home screen. So you can find, obviously, you can search for patients and you can find patient records. So like here's Mary Miller, and we look at her, and she injured her wrist or her hip or thigh, and she needs to do some more exercise for shortness of breath. And you could start visits, you could look at past visits, you could merge visits, or schedule or request appointments. This is what kind of doctors would typically do. You can look at active visits, you can register a new patient. So if I were to come for the first time, I would register myself. And what else do we have? Appointment scheduling, data management. This is quite interesting. Here you can merge two patient records. So if a given patient, a single person, has been to hospital twice and kind of registered twice, you can merge those records. And I want to have a bit closer look at the systems administration. So let's move on to the advanced administration. Right. So here you see all the underlying concepts. So this is what we discussed in the data model view. We've got users, we've got roles, we've got the patients, we've got persons or people, visits, and so forth. And this is the concept dictionary. And so, for example, manage concept data types. Just a sec. Nope, that was actually not what I was. So we can view the concept dictionary. That's what I was looking for. So as I described before, when I go for blood, I find all these things like a blood sample, blood pressure, and oxygen saturation, and so forth. And here in the administration, I would also manage modules. So this is a view of the modules which are currently running in this installation. And if someone provided a new module and I want to use that, I can say upgrade or add a module and say I want to do something about managing addresses. I would go here, and these are modules which are currently available around addresses. So here, for example, the one in the middle, address hierarchy, allows for the entry of structured addresses. So I could pull that and I could start using it in my installation straight away. So going back to the deck, how does the underlying tech stack look? It is pretty bare bones, so it is nothing exciting. So we have Java, Spring, Hibernate, MySQL, and Tomcat, or it could be Jetty as well. This is the core of OpenMRS. And the user interface we've just looked at is fairly recent. So I guess it's about a couple of years old, and before that it looked a bit more kind of old-fashioned, like in the administrator screen, the last few screens we looked at. And from a technical viewpoint, it is not super exciting. When looking at the different modules, you find all kinds of technologies that are used by people implementing the modules. And this is kind of a mixed blessing. So if you want to work on OpenMRS and contribute to OpenMRS, I reckon you would not do so because you find the greatest and latest and super exciting technology. This is more about contributing to a system that is used worldwide to improve human welfare. And that's kind of the underlying driver. So if you find, say, 5 modules, and they all use 5 different tech stacks, which have been the very exciting, the latest and greatest at the time these modules were developed, it's a mixed blessing because the system needs to be maintained. And if the overall tech stack becomes very fragmented, it becomes more difficult to maintain it. So I started working on OpenMRS in 2013, and so I got interested in it. I learned about it from colleagues, and I started by just looking at a first ticket. So the work to be done is organized in tickets in the Jira system, and my first ticket was about improving search for people and was related to the searchable attributes of people. And so I got the code base and I forked the OpenMRS GitHub repository and created a branch for the story I was working on and started coding away. And the code I looked at made me think initially, wow, this is a very old code base and it's not tested enough. I wish I could throw it away and rewrite it. This was my first reaction when looking at the code base. However, this system is in production and it is affecting people's lives. So you cannot just stop and you cannot just say, hey, dear people going to hospital, maybe here's the deal. If you start falling sick for the next couple of years, we rewrite the system, we've got a shiny new system. And then you can start becoming sick again. This just doesn't happen. So I learned a few things around the code base. When working on these stories, more often than not, I was firstly writing many tests to kind of providing a test base so that I could safely change the code base. Another thing I learned was the tickets you read, the tickets you're getting from the OpenMRS community, sometimes they are really old, and sometimes people have started working on a ticket and have dropped the ticket, then someone else has started and dropped off. And so if you look at the ticket history, it may be very long. And sometimes it's difficult to understand, okay, what's the actual requirement underneath? But it's easy to resolve, just talk to the people. So when I asked my first question around the search ticket, the answer I got was start by writing a test. This was really good advice, but actually my question had been around what is this story meant to do from a business viewpoint? Should I go left or right? I could see two options. And so I just got in touch with people. We had a few Skype sessions, and I participated in a few sessions where kind of OpenMRS people which have the bigger picture in mind, look at, okay, if you go this way, these are the implications in the midterm, and we decided which way to go. And this ticket I think it took about half a year to resolve, and there was a big pause in between. So I had submitted my code, and it took quite a while to get it reviewed. But that was exceptional. More often than not, you submit a pull request for a change, and it is reviewed, and you get feedback, and you just refine, and then you can finish that particular ticket. Another thing I learned from working at the code base, and that really affected the way I'm working in projects today or since then, is to triage. And this is interesting because triage comes as effectively a medical term. It means, okay, I've got 3 patients, I can only treat one of them at a time. Whom do I choose first? So kind of who's in most need of stuff being done. So it's easy to get lost in a ticket and kind of overdo Boy Scouting by saying, well, I've done my ticket, but I found so many other things. I would like to address those as well and change those things as well. And this is where I learned to kind of restrain myself and say, okay, I've done the ticket, I've done some stuff left and right, but now I just finish work on that one, and I let other people decide what's the next most important thing to work on. So let's have a look at Bahmni, quick look. Bahmni is the next generation hospital system. So it's doing more than OpenMRS is doing. So it's doing medical records and patient management. This is the core domain of OpenMRS, and actually Bahmni is based on OpenMRS for that purpose. But we've got three more dimensions in here. So you've got ERP system, inventory, billing and accounting. This is more around managing a hospital. Then rather than treating patients, there's a lab management system in there and an image archive. And all these components are based on existing open source software. And it has been pulled together into Bahmni. And so ThoughtWorks is quite active in that space. So we are rolling out Bahmni and before OpenMRS in hospitals in India. And at times, we also get work from clients in that space. So we also contributed to getting OpenMRS/Bahmni up and running in Haiti, in hospital rebuild after the earthquake. And so another thing is you're probably aware of the kind of Ebola crisis that happened in Africa over the last couple of years. And a colleague of mine, he actually went there and worked he's a medical, so he's a trained doctor. And he worked in the Ebola camp. And we learned in the camp that it's one of the things that's really hard for them to work efficiently is in an Ebola camp, you've got what's called a red zone and a green zone. So the red zone is contaminated, so nothing should leave the red zone. And doctors and medical staff only go there wearing these kind of astronaut or kind of the space suits. And it's difficult to capture information about patients who are treated in the red zone. So what they used to do, they went to a fence or a double fence. So someone was in the red zone and someone was outside in the green zone. And the person in the red zone was shouting his or her findings over the double fence into the green zone, and someone was taking notes there. Because you couldn't use a laptop or a computer with your spacesuit. So what we did is we developed a user interface that could be used from a spacesuit. So effectively, doctors then took tablets into the red zone, and they could they could enter patient data straight away. So we provided a new user interface. And this is just one example how you can easily change and respond, can change livelihood of people and respond to a concrete need. So let's move on and think a little bit about how does contributing to OpenMRS work. So as I mentioned before, the OpenMRS community has organized their requirements in tickets. And if you want to work on OpenMRS, you get interested, you register, you get an identifier, username and password, and then you can log on and have a look at all the tickets that are available. And they come in different layers, if you like. So there's a section that's called Introductory Tickets, and these are supposed to get started on, so they are kind of fairly easy and kind of small changes. It takes some time if you go into the system, to understand what is going on, understand the design and the underlying architecture, or how does the data model look like. It is quite well documented in the OpenMRS wiki. So introductory tickets are good for getting started. Then there are tickets for community developers, and they are kind of a little bit advanced, if I may say so. And last but not least, there are kind of projects. And projects tend to deal with modules. It's a larger thing. It would probably not be something you would work on your own, but rather in a team. It could be a distributed team, or it could be a co-located team. And once you decided to work on a ticket, so you claim a ticket. As I mentioned before, you fork the OpenMRS Git repository. So the OpenMRS people like to have branches on your fork for each ticket. So you create a branch with the ticket number, you work on the tickets, and then you submit a pull request. And it's being reviewed, and eventually it's being merged into the code base. And that's quite interesting. So when I did my first ticket about the search, there was a second ticket. So altogether, I worked a year on search in OpenMRS for 2 tickets. And it's interesting to observe how the community responds, and kind of decisions that are taken. So after I've done the second ticket, and all this was about improving search. So I had mentioned the searchable attributes of people, and they existed in the data model, but they were not supported by the search at the time I started working on that. So I made them kind of truly searchable. And then I first did it for kind of people, and then again for patients. And then I got an email, or someone in Israel observed kind of, now hang on, you've just implemented that one on a particular release. We would like to have it in our release as well. So they were using kind of an older release. So the question was, can it be backported into the older version? But the OpenMRS community kind of decided against that. They said, no, we don't want to invest getting all the features back into the version you are using. We would rather advise, if you could upgrade your version, then you get all the stuff you need. Right. Actually, sample tickets, I guess I already covered most of that by telling some war stories. It is, as I said, it's important to understand what's going on in a ticket. So if you don't understand it, just reach out to people and have a discussion and see what's going on. So let's talk about code jams. Code jams are kind of people getting together, either for a couple of hours or 4 hours in an evening, or during a weekend or a Saturday, and work on OpenMRS as a group. And if it's good to get started working on tickets by yourself, or maybe find a pair and work in a small team. And once you develop an understanding and have submitted the first tickets by yourself, you may be interested in organizing code jams around that. So what's the recipe for a code jam? First and foremost, you need people. Without people, you can't really do a code jam. And you need things to work on. And this should be well prepared. So when doing code jams, people coming along for the first time, they would need to set up their development environment. And we like to ask people, if you come along, if you attend the code jam, please be prepared and set up your development environment up front. There are recipes available in the OpenMRS wiki that tell you how to do so. And there are different styles of setting up your development environment. You can kind of just pull the code base and start it locally on a Jetty or on a Tomcat when you want to have test runs, or you can work against Docker containers. This is more recent. And so you can do it in different ways. Thing is, sometimes there are hiccups, and these are kind of known hiccups, but it's kind of annoying when you want to run a code jam and you spend half of the day getting everybody on board from a technical viewpoint. So it's really nice if people come along and have already set up their machine. So we kindly invite people, great, you're planning to come along, would you mind setting up your machine? And we give them a gentle reminder, maybe a week before the code jam, and kind of they may ask questions, this is not working for me, what can I do about it? So ideally they would come technically ready, prepared. But the other dimension is, what are the things to work on, the stories for the code jam? They need to be prepared as well. So what we like to do is we go to the OpenMRS Jira system and we just look for a mix of stories of different, say, levels of difficulty, and say, these are nice ones, you would like to reserve them for the code jam. So we just claim them, and so we earmark them and put in a note, this is reserved for a code jam. During the code jam, they're either being worked on, ideally they are being resolved, or they may just be left aside because people were doing other stories, and then it's important to unclaim them. But also when claiming those tickets, we need to understand what they are about. And we try to find people who are available to answer questions. This goes across time zones, and it may be tricky at times, but it's always helpful to have someone you can ask. If you just grab a story and halfway through the story you realize you don't really know what this story is meant to change in the code base, you have lost half a day of effort. So prepare them well from a business analysis viewpoint. You need a location. So typically our office, or maybe some office or the client space, sometimes we're doing this stuff. And the most tricky part is you need to keep going. And this is really a difficult one. So I found in the last few years, and my colleagues in Europe have kind of made similar experiences, it's easy to get people interested. But it's difficult to get continuity into the game and say, have a group that continues working on a module or just on stories, just on tickets, over an extended period in time. And what we found is, so people are really excited, they like to come along, they enjoy the code jam, they learn something, they do contribute, and so they are kind of genuinely interested in OpenMRS, but then interest kind of fades away and drops off. And this may result in that we have nice code jams, we have a good day, so we get some pizza, we get to learn new people, and we have fun coding and learn something about technology. But the actual lines of code, number of lines of code produced for OpenMRS may be very small. And this kind of means we are missing the point, because this is about making a better world, coding a better world. It's not about us having fun during the code jam. I don't have the silver bullet answer to that one, so we try different things. And for example, I went to a group near Cologne in Germany for a few times. So they are running kind of meetups on Friday evenings and from 6 to 10. And I did code jams with this group, don't know, maybe 3-4 times. And this was really strange. So they really enjoyed this. And then at the end of the code jam, when I asked, okay, this ticket you started working on, would you mind finishing it in your spare time, or would you be interested in having a code jam, say, on a weekend? They clearly responded no. And then I asked, well, did you find this interesting? And they said yes. And I asked, shall we do it again? And they said yes. but there was a clear separation between prepared to invest these 4 hours on a Friday night, which is much appreciated, but no, we don't have time to do anything else. And they explained, they said, well, we've got a family to look after, and so sorry, we just don't have enough time for that. So we tried reaching out to students, and the first try didn't go that well. So we were thinking, okay, we need people who are interested, who are enthusiastic, and who have plenty of time, so possibly students. What are they doing all day anyway? And so I got in touch with the university, and we, during a master's course in computer science, students typically do have to do some internship, or they spend 1 term, so half a year, half their time on a real project, and they need to look for the project. So we put up an offer and say, okay, what if a group of, say, 4 or 5 or 6 students got together and worked on OpenMRS for half a year? And what's in it for the students? They learn kind of maintaining a real-world system, a code base that is in production. And we also offered some coaching and some help. So we would have gone there, say, once a month and to meet them for a day and have some kind of remote coaching in between. But nobody picked up that offer. And that was quite eye-opening or disappointing, to be honest. So we don't know yet why that is the case, and we want to try it again. So keeping going is a difficult thing. Personally, I find this kind of super rewarding. So there's more to life as a software engineer than just building the next shopping basket and kind of increasing conversion rate. I'm doing this for a living, so I'm earning my money by increasing conversion rates. But to be honest, it's less rewarding than contributing to this kind of code base. And there are many more systems around like that one. So there's a system called Rapid FTR, which is used by UNICEF, and this is open source software as well. It's used for tracing people, in particular children, who get lost in a crisis. So when people are kind of fleeing a location and they end up in refugee camps, they may be scattered across many refugee camps. And when children get lost, it's particularly difficult because they may just disappear. You never trace them back, and they may be trafficked or they may become slaves. And traditionally, people went from camp to camp and kind of trying to trace family members, and this is very inefficient. So imagine working for days and then you go to another camp and then you try to find the children. So the system supports people from UNICEF working in the camps to capture information about children who went missing, and then ideally they would get a picture, or they can ask the children who are kind of alone, can we take your picture, and what's your name, and what's the name of your relatives, and where do you come from? So you support this family reunification by very simple means of IT. There is a system called Mifos X. This is around microfinance, so offering financial products to people in countries who traditionally do not have access to financial products, such as it could be micro savings, or it could be micro credit or micro loan, so people can start a business. And very recently, colleagues of mine started working on it's in production, a mobile app which is used in refugee camps in Greece. So when people arrive there and they don't speak Greece or they don't speak English, so it's kind of a translation card, so very simple phrases, or the typical phrases that are being used when registering and helping a refugee. Once they arrive on one of the Greek islands, they are kind of available in this app, and so people can communicate with the help of this app. So there are many of these systems you could be working on, and it would be great if you take away the idea of changing the world by code from this session. So that's my talk, and do we have any questions? Yes, please. We do have a microphone here. I probably just... Okay, if you just shout at me and I shall repeat for... Can you tell a little bit about security? Right. Medical doctors access to patients. Right. Yeah. So the question is about security. Can anybody access any data of the system? And in the system, there are different roles. So not anybody can do anything. I just logged in as administrator, so I could see a lot of things. I don't know whether as administrator I would be allowed to change patient data. Probably I shouldn't be. But as a doctor, when I'm medical staff, I cannot change system configuration. This is an interesting question. It often comes up at conferences when talking about OpenMRS. And so how secure is the data inside the system? And the answer is, it is as secure as the system is being operated. That's kind of the honest answer, which may or may not surprise you. So OpenMRS runs on a large bandwidth of tech stacks. I could run it on my machine, and you could just run it on a desktop computer sitting underneath a desk in a hospital. Or you could run it in a kind of proper data center, or you could run it in a cloud. So you've got a wide range of usage scenarios. And at the end of the day, people operating the system need to ensure security from how do I protect this data from being stolen or being abused. But yes, to answer your question, there are different roles. There's a role model in OpenMRS. Do we have more questions? Right. So the question is, in order to deploy, do you meet some regulatory requirements? Has the system been audited? By knowing the code base from the inside, I'm pretty sure this system has not been audited, or it wouldn't pass a technical audit. However, as I said before, this system is saving people's lives. It is in production. And so this is what surprises me whenever I look at the OpenMRS Atlas. How can it be used in the US or in Europe? I guess these are kind of private institutions or maybe research teams at universities who are using this. So I'm pretty sure, I don't know this exactly, but I'm pretty sure if I were to try to use this in a hospital in Poland or say in Germany or say in the United States, it would not be allowed. The license of OpenMRS it's based on, I think it's the Mozilla license for open source software, extended by one statement, which reads like, this system does not take any medical decisions. Any medical decision needs to be taken by a doctor, someone trained. So do not use this system to make it take decisions for you. So kind of use it at your own risk. And again, what's the trade-off here? So as I said, if I could rewrite it and I could get it audited, yes, it would be a better system. But right now, the choice is, do we leave people with paper-based records alone, and they still rely on paper-based records, or do we give them this kind of system? And we can improve this kind of system. So in a sense, it's our decision. If we can make this a better system, and then helping to make it a better world. Most of the hospitals where it is being used simply cannot afford commercial systems. So they don't have a choice. They can use this one or paper-based records. Thank you. There were two more questions around here. Yes. Right. Okay, so the question is, when I have two modules and they are extending the data model, can they share the extension? I haven't tried this, but I would assume so. It would be kind of a dependency where you say, I'm using module A, and I also want to use module B, and module B requires module A. I don't know whether this can be expressed in terms of modules, that if I want to use module B, it's raising its hand and says, oh yeah, by the way, you need module A, but I wouldn't see why this would not be possible. Because ideally, any extensions to the data model would be in the underlying relational data store, which is MySQL, and not in some other persistence technology. Right. Do we have? Yes, please, go on. Yes. As I'm aware of, they are kind of, it's deployed independently, so different aspects need to be taken into. It depends on the location. So it depends kind of, do you have internet connectivity? Kind of at what times do you have internet connectivity? Down to, do you have power supply at all? At what times do you have power supply? So the hospitals my Indian colleagues went to and helped setting up OpenMRS, they run it kind of on their own hardware, on their premises. And if you can rely on power supply and internet connectivity, then you could run it in the cloud and then say hospitals may share it. I don't know whether this is actually happening. Sorry? You can, sorry, the question is there a protocol that information can be shared between instances? There is, for example, the concept dictionary, so you can download a concept dictionary and you can kind of upload these proposals, so data can be exchanged. I'm not sure whether data can be exchanged at patient level, but I think the system in Haiti, they are running this on a proper operation setup with kind of a failover, so this is kind of a serious installation. It's all scales. So it needs, one requirement is the system needs to run on an old machine sitting under the desk. Because otherwise, OpenMRS would kind of drop and leave behind potential users who just don't have the kind of hardware capabilities. Yes, please. Right. Okay, so the question is there a global way to exchange information and learnings from one installation to another one? There is a large community around that, and there are kind of conferences where OpenMRS people meet and kind of talk about what's the direction of OpenMRS. I haven't looked at the system from this kind of medical person, doctor perspective. I don't know whether it's technically supported to exchange this information, but what OpenMRS supports, and this was one of the requirements when it was started, is kind of, it allows you to define studies or queries where you say you just define a sample of patients, and you can search and say I want patients, kind of should be male patients, should be between 30 and 40, should be living in that region, and should have suffering from a particular disease or whatever criteria you compile, and then you can analyze the effectivity of treatment on these samples. So it helps you understanding whether treatment is working or whether it's not working. So you can analyze it from a scientific viewpoint. How this information is then disseminated in the OpenMRS community, I don't know. Yeah, so there's quite a large, sorry, the question was about the future of OpenMRS and kind of which way would it go on. So if you look at the open tickets, there are kind of many tickets. So I wouldn't see it being ready or it being done. Some tickets are just related to bugs. Some tickets are kind of old requirements that just always got overtaken by more important requirements, but there is kind of new stuff going on there. And so the future is Bahmni. Bahmni is the full-fledged system which is allowing you to operate the hospital completely from all kinds of viewpoints. And yeah, stuff is being worked on. So it's not going to go away. So I don't expect us to find a situation where we say, it's done. Nothing needs to be continued on that particular system. Yeah, and another one. Yeah, you go first. Yes, yeah. There are, so the question is kind of who's having the big picture, who's having the grand vision. So it was kickstarted by two NGOs based in the US. And sometimes people ask, is this being imposed on the Global South by the Global North? And are we telling them how to do things? This is not the case. So today the community is getting feedback from people using OpenMRS. And just as when we develop our software, it's driven by feedback of those people, and they say, these are the requirements, this is what we need in the field. Or like the user interface for spacesuits in Ebola as an example. So you figured out, hang on, in this particular situation, it is being used, got a requirement, and so find someone to implement it.
Are you aware of a commercial system based on OpenMRS?
So question is there a commercial system based on OpenMRS? I'm not aware. I haven't asked myself that particular question. And so the kind of regulation, as discussed before, would probably kick in and prevent that. And my gut feeling is, well, this is open source. What would be a kind of a viable commercial model? I would not want to see it a commercial model where someone is making money and excluding users from it. So the idea of humanitarian software, and in particular humanitarian open source software, is to make things available to people who just don't have them for whatever reason. So we are lucky. When we go to the doctor, we are well treated, and we've got all the infrastructure we could be asking for. So we were born into a privileged situation, and I'm just lucky. That's all. And so I wouldn't want to see someone making money off OpenMRS, if that means it becomes less accessible to people who need it more than I, or people who can pay the money. Yes, please. Right. So the question is there competition in this space? I don't know, to be honest, but I haven't. I guess no. I think there are more systems, but I can't. One of my colleagues pointed me to some systems some other day, but I wouldn't know how they relate and are they kind of big players. Perhaps one more question, and then I guess we are running out of time, if there is a question. Otherwise, thank you very much. Have a look by yourself at OpenMRS. So there are a bunch of resources available. So just go to openmrs.org, and from there you find all the other pointers. There's a wiki, there are the tickets, and there's a bunch of GitHub repositories. And thank you for attending. Thank you.